So today I'm going to show you how to find the limit of as x approaches -3 of x squared minus 2x minus 15 all over x cubed plus 27. So the first thing you want to do is prove that if you go ahead and plug in -3 for all of your x values, that you'll get 0 over 0, which you can't have. So you would plug in -3 squared minus 2 times -3 minus 15 all over -3 squared plus 27. So that would come out to 9 minus 8, not 18, plus 6 minus 15. So those would come out to 15, so that would equal 0. 15 minus 15 is 0. And then this would come out to -27 minus 27 equals 0. So there you go, 0 over 0. So from here, you can continue on other ways to solve. So I'm going to show you how to factor this and then solve. So you want to always make sure you have your limit notation. So that's the limit as x approaches -3 of x squared minus 2x minus 15 all over x cubed plus 27. So to factor it, keep your limit notation x approaching -3. So for the top, you basically just need to unfoil it. So your factors would come out to be x plus 3 and x minus 5. And you can real quick just check it by refoiling everything first, opposite, inside, last. And then it should come out to that, the top over here. And then so for the denominator, you want to factor using a plus b times a minus ab plus b. So that comes out to x plus 3 times x minus 3x plus 9. So from there you can cancel out like factors. You can cancel out an x plus 3 in the top and an x plus 3 in the bottom. So that leaves you with the limit as x approaches -3 of x minus 5 all over x squared minus 3x, that should have been squared up here, sorry, plus 9. So from here you can just go ahead and plug in -3 into all the x values, because it will not equal 0 over 0 anymore. So that equals, at this point you can get rid of the limit notation because you are plugging in the limit. So that equals -3 minus 5 all over -3 squared minus 3x, or sorry, not 3x, -3 times -3 plus 9. And that equals -8 all over, so this would be 9 minus 9 plus 9. So these two would cancel, so that just leaves you with 9. Oh, I see what I did wrong. So this would be positive. No canceling, I'm sorry. 27. Okay, so that equals about, if you plug it into your calculator, which I have a nice handy old TI-84, and okay, so -8 divided by 27 equals about, what's wrong? We're just going to delete that. We know that there's a, so it equals about -0.296. And for the AP test, you always want to round up to the third decimal value. Okay, so that's solving by algebra. So now I'm going to show you how to solve by graphing. And we're just going to make a nice little handy dandy little graph here. So you can, I'm going to do this easy. I'm just going to plug it into my calculator. So you do x squared minus 2x minus 15, and this is just to get the x values, or points. It'll be quicker. And then divided by x to the power of 3 plus 27, close parentheses, and then you graph it, and then if, see, it looks at, and it's up looking like that. And then if you press second and then table, and then I have it set to ask, which I'll show you how to do in a minute. If you set it to auto, go back to table, it'll give you points. So our closest point would be at 5, where x equals 5. 1, 2, 3, 4, 5. It equals 0. And then up here, since you canceled out 2 factors, you're going to have a hole where when you set this to equal to 0, so you'd have x plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. So at x equals negative 3, you're going to have a hole in your graph. So we go back and have it ask for the independent values. At negative 3, you'll see there's an error. So it ends up being like a little right here, and you have an open circle because it cannot equal that. But there's an error because there's a limit at this point, at where x equals 3. So just looking off of this, you can kind of tell it just kind of goes do 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 do. Yeah, it kind of looks like that. See, yeah. Oh, you can't see. See, graphy graph. So based off of that, you can just look as x is approaching from the left and of the right of where x equals 3. You would know that x is approaching negative 0.296 if you were using a calculator. Okay, so next I'm going to show you by using a table. So when you are solving with a table, you basically just plug in values that are close to your limit. So you're going to start off with negative 3 in the middle, and here you can either say it's undefined or it does not exist. I would use does not exist because that's what the AP test uses. So, and then when you're doing this, you're just slowly getting farther and farther away from negative 3. So you go negative 2.999, and then negative 2.99, and then you go negative 2.9, and then over here you do the same thing, just going the other direction. So negative 3.001, then negative 3.01, then last negative 3.1. And as you can see, you're just slowly getting farther and farther away from negative 3. So with these x values that you have up here, because this is x and this is y, you plug these x values into the equation back up here. And so there's an easy way to do that in your calculator. So whenever you plug it in, and then you press second table set, and you go down to the, I don't know what's happening here. Go to the independent value. Okay, let me just turn this back on. There you go. And you set it to ask for the x values, and you press second and then go to table, and you can tell it which x values you want. So I'm going to start off with over here, so negative 2.9, x equals about negative 0.302. And then at negative 2.99, x equals about negative 2.96. No, 97, because you want to round up. And then at negative 2.999, oops, typo 9, x equals about negative 2.296. So that's from that side. So now we're going to go to the other side and go negative 0.3001. Y equals about negative 0.296 again, and then negative 3.01, x equals about negative 0.296, and again, you're rounding up to negative 0.296 instead of negative 0.295, and then negative 3.1, y equals negative 0.290. So as you can see, as x is getting closer and closer and closer to negative 3 from both sides, it's approaching negative 2.96. So from that, you can just assume that the limit as x approaches negative 3 from the left of x squared minus 2x minus 15 all over x cubed plus 27 equals negative 0.296. And that's how you solve the limit of x as x approaches 3 of that equation. Thank you.